For question number 4, we are factoring 12x squared plus 13x minus 4. Like all the previous examples, we look at the coefficients of each of them to see if there's a common factor that we can just pull out to make our problem a little bit simpler. The factors of 12 are 1, 2, 3, 4, 6, and 12. For 13, it's just 1 and 13, since that's a prime number. It's not looking good. And for negative 4, we have 1, 2, and 4. Unfortunately, none of those numbers have a common factor that's greater than 1 that would make our problem simpler. So we just have to stick with the problem we have, 12x squared plus 13x minus 4. All right, to do this problem, we first need to multiply the a and the c terms together to get one number, and then we will list all factor pairs of that number, which is 12 times negative 4 equals negative 48. Now, we're going to find all the factor pairs of negative 48 and add them up to see if any of them equal the b term, which is 13, positive 13. So in all our factor pairs, we're going to make the larger of the two numbers be positive and the smaller one be negative, so that when they're added together, it will equal a positive number. All right, so the factor pairs are negative 1 times 48, negative 2 times 24, negative 3 times 16, negative 4 times 12, and negative 6 times 8. Now, let's add all of those together individually. Negative 1 plus 48 is negative 47. That doesn't equal 13. Negative 2 times 24 is 22. Negative 3 times 16, negative 3 plus 16 is 13. Negative 4 plus 12 is 8. And negative 6 plus 8 is 2. The term that we're going to use is that middle term, negative 3 and 16, because that factor pair adds up to be the b term of 13. So what we're going to do is we're going to replace that 13x in the original expression with negative 3x plus 16x, because if we just add those together, we get that b term. And we get 12x squared minus 3x plus 16x minus 4. What we're going to do next is we're going to place parentheses around the first two terms and the second two terms to factor by grouping. Okay? If we look at the 12x squared minus 3x, they each have a common factor of 3x. So we can factor that 3x out of those two terms. And we're left with 12x squared divided by 3x is 4x. And negative 3x divided by 3x is negative 1. So our factor becomes 3x, which is one linear expression, times 4x minus 1. And when we have the 16x minus 4, we can factor out a 4. 16x divided by 4 is 4x. And negative 4 divided by 4 is just 1. So our expression is 4 times 4x minus 1. Now, we look at both of them, and each of them have a factor of 4x minus 1. Since, just like everything else, just like we did before, if you have the same exact term in both expressions, we can pull it to the front. And we would get 3x plus 4 times 4x minus 1. The 3x came from the coefficient here, and the 4 came from the coefficient of the second expression. So 3x plus 4, the coefficients, and the value in the middle was 4x minus 1. So our final expression is 4x minus 1 times 3x plus 4, or the commutative property of multiplication states we could switch it, 3x plus 4 times 4x minus 1. I'll be back in a second with the final example.